Okay, so now let's see how a sum of independent Poisson random variables turn out to be. So let's assume that we have x1, which is Poisson with parameter lambda 1, and x2, which is Poisson with parameter lambda 2, and we have a random variable y, which is the sum of x1 and x2. So now we want to find the PMF of y. So PMF of y is P of y is equal to y. So this is equal to so we will see this index of summation later. X1 is equal to x1 and x2 is equal to y minus x2. Now we know that a Poisson random variable goes from 0 to infinity, so x1 should start from 0. But what is the maximum value of x1? Now x2 can also not be negative, right? So then the maximum value of x1 should be just y. So now using the independence property, we can say that this is equal to x1 is equal to 0 to y, probability x1 is equal to x1, probability x2 is equal to y minus x1. Okay, now we apply the PMF of a Poisson random variable. So then this guy is equal to x1 is equal to 0 to y e to the minus lambda 1 to the x1 divided by x factorial. Now this guy is e to the minus lambda 2 to the power of y minus x1 divided by y minus x1 factorial. Now let us isolate the terms which are independent of the summation. So we can take e to the minus lambda 1 and lambda 2 out, so that it becomes e to the minus lambda 1 plus lambda 2, and then I don't think we can take anything else out. This is x1. So then this is x1 is equal to 0 to y lambda 1 x1 lambda 2 y minus x1 divided by x1 factorial y minus x1 factorial. Now for this summation, can I multiply by y factorial and multiply by 1 over y factorial here? I can do that, right? Okay, so then what is this term? This term is nothing but y choose x1. Okay, so now our PMF is e to the minus lambda 1 plus lambda 2 divided by y factorial times x1 is equal to 0 to y choose x1 lambda 1 x1 lambda 2 y minus x1. Now this is what? This is nothing but the binomial expansion of lambda 1 plus lambda 2 to the power of y. Okay, so then our PMF of y is e to the minus lambda 1 plus lambda 2 divided by y factorial times lambda 1 plus lambda 2 to the power of y. Now you can see that this is exactly a Poisson random variable, but the parameter now is lambda 1 plus lambda 2. So then this means y is Poisson with parameters lambda 1 plus lambda 2. Now this can be extended to n random variables. So if you have y, let's make it z, this is I is equal to 1 to n xi, where xi's are all Poisson with parameter lambda I. So then z will be Poisson with parameter I is equal to 1 to n lambda I. Okay, so this is a very simple proof to how to find the sum of independent Poisson random variables. Just the only trick is to note that this guy is actually a binomial expansion, and to come to from this step to this step. Hope you understand the video well, and hope you like the video. Thanks for watching.